Alright, in this video here we're going to talk about local or relative minimum and maximum points and what they look at on the graph, or what they look like on the graph, how to find them, and what the definitions of those things are. So first off, depending on the book that you use and the author who wrote the book, some people use the term local maximum, local minimum, others use the term relative maximum, relative minimum. They mean the same thing, right? So they're interchangeable terms. Some books refer to them as locals, some of them refer to as relative maximums and minimums, but they mean the same thing, so don't worry about it. The book that I use uses the word local, so that's what I'm going to use, but if your book uses relative, then that's fine. So f has a local maximum point at x equals a if f of a is greater than or equal to f of x when x is near a. Right? So first thing, I usually abbreviate maximum and minimum as max and min because they're just too big of a words to write all over and over again. So at x equals a, which maybe I should put at x equals a here. All right, so at that x value, a local maximum or a relative maximum basically means it's the highest point in that neighborhood. Right? So when x is near a, so somewhere in that neighborhood around that point a, right, that x value there, f of a, the y coordinate of that point, is greater than or equal to f of x, all the other y coordinates of all those other x values that are in that neighborhood. Right, so in that little neighborhood there, that's the highest point around. We call that a local maximum point. Right, now, if you watch the video that I did on increasing and decreasing and what those look like on the graph, it's the same idea here. Right. Maximum and minimum, if you speak the English language, you know what the words maximum and minimum mean. So if you look at a graph, like, it's pretty easy to point out the local maximum, the local minimum points. They mean what you think they would mean, right? But when you start looking at the mathematical definitions, sometimes the definitions make them seem more complicated, right? So a local maximum, to put it plainly, if it's the highest point in the neighborhood, is a local maximum point. Right, local minimum point, if it's the lowest point in that area or in that neighborhood, is going to be a local minimum point. Right, the technical definition, f has a local minimum at x equals a if f of a is less than or equal to f of x when x is near a. Right, so if I'm on this x coordinate a, and the f of a, the y coordinate for that point, is less than or equal to, so it's lower than f of x, all the other y values that are near that point, well, then that's the local minimum point or relative minimum point. All right, so again, the highest point in the neighborhood is a local maximum point. The lowest point in a neighborhood is a local minimum point. All right, and graphs can have multiple local maximums and multiple local minimum points. Right, they don't have to have just one. Some graphs don't have either one. Like if you take a graph of just like a linear function like this, right, that graph does not have any local maximum or local minimum points. It never reaches a high point, it never reaches a low point. One end goes up forever, the other end goes down forever. It never reaches a high point or a low point. Right, another way to think about local maximums, local minimums, a local maximum point is like the top of a hill. Or if you think of a graph that has curves to it, if your graph ever reaches the top of a hill, that's a local maximum point. Right, a local minimum point is like the bottom of a valley. Right, so if your graph ever bottoms out or hits the bottom of a valley, that's going to be a local minimum point. All right, and again, graphs can have more than one. So if I draw a graph that looks like this, well, this graph has two local minimum points and it has two local maximum points. Right, it hits the top of a hill 2 different times. It hits the bottom of a valley 2 different times. It can have multiple local maximums and minimums. All right, and it doesn't matter which one of those is higher or which one is lower. In this neighborhood, that's the highest point around, so that's a local maximum point. In this other neighborhood, that's the highest point around, so it's another local maximum point. All right, so that's the meaning of a local maximum and a local minimum. Again, it's pretty easy to identify. Top of a hill, bottom of a valley. That's really all there is to it as far as identifying local maximums and local minimum points. All right, so for this graph up here, so I drew up here the graph of a function, and we're just going to say, where does this graph have a local maximum, where does it have a local minimum? All right, so the local maximum point is at x equals 1. I didn't label any of these points here, I probably should have. But at x equals 1, that's when that graph reaches that highest point in that neighborhood. So the local maximum point is at x equals 1. The local local maximum value would be would be y equals 5. Right, so the local maximum value is 5 the local maximum occurs when x equals 1. Right? So there's two different ways to answer that question depending on how it's worded. If the question says, where does this graph have a local maximum, the answer is it has a local maximum at x equals 1. If the question says, what is the local maximum value of this graph, it would be 5, right? Because that's the y-coordinate of that point. That's the actual value of the function when x equals 1. So the local maximum value is 5. The local maximum occurs at x equals 1. All right. Same idea for a local minimum. Right? Where does this graph have a local minimum? It's going to be at x equals -2. Right? -1, -2. That's where this graph reaches that low point, that bottom of the valley. So local minimum is at x equals -2. But if it asks me for the local minimum value, now it's asking me for the value of the function, which is the y-coordinate, which would be -3. Right? So my local minimum value there would be a -3. Right? So where the minimum occurs and what the minimum value is, where the minimum occurs is the x value. What the local minimum value is the y-coordinate of that point. All right, so that's local or relative maximum and minimum points. Again, pretty simple to identify. One other thing to point out, again, I think I mentioned this a few minutes ago, but the video that I did on increasing and decreasing functions, just if any of you go on to take calculus beyond this, it's something important to know for calculus. But a local minimum value is going to occur where your graph changes from decreasing to increasing. Right? That point where it switches from decreasing to increasing, that transition point is your local minimum point. And if your graph changes from increasing to decreasing, that point where it transitions from one to the other, that's your local maximum point. Right? So local maximums and minimums occur where your graph changes, increasing, decreasing, or vice versa. Right? So again, when you talk about calculus, so if you ever get into that class, that's kind of an important thing to realize when you're talking about local maximums and local minimum points. All right. Other than that, though, like I said, they're pretty easy to identify. You're just looking for the top of a hill or the bottom of a valley. Also notice, my local maximum point is not the highest point on the graph. Right? This graph on this side over here is going to keep on going up forever. So the local maximum is not the highest point anywhere on the graph. It's just the highest point in this neighborhood of the graph. Right? That's why they call it a local or a relative maximum point. In that neighborhood, in that locality, or relative to the points around it, it's the highest point, even though the graph goes higher over here. Right? Same for the relative minimum or the local minimum. It's the lowest point in that neighborhood, even though over here the graph goes lower than that. Right? So local, relative maximum, and minimums, not necessarily the highest and lowest points anywhere on the graph, just the highest and lowest points in those neighborhoods. Again, top of a hill, bottom of a valley, that's where you have local maximums, local minimums.